Angles are a very important part of geometry, obviously. They show up all over the place when we're talking about polygons and parallel lines and things like that. And they also play an important role in advanced mathematics when we get into algebra and calculus. And the angles are very important because they have to do with trigonometry ratios that give us functions that deal with circles or oscillating functions. So angles are real important. Now, we're used to seeing angles in geometry when we're talking about triangles and squares and polygons and all the angles that we're used to seeing are angles that are usually between the 0 and 180 degrees, right? Okay, we got obtuse angles, we got acute angles. Well, we're going to take that idea and we're going to stretch it a little bit further so that we can have angles of any size. And then we're going to look at another way to measure angles. So far, you've measured angles by degrees. And we know that a full circle is 360 degrees all the way around a circle. Why 360? Seems like kind of an arbitrary number that somebody just kind of made up. If you look back in history, it has something to do with a full circle. In a full year, the Earth goes around the sun in about 360 days. And some ancient calendars had 360 days. So it has something to do with that there. And anyways, but degrees are numbers that we measure angles with, but it doesn't mean too much to us. We like a better way. And we're going to call that way of measuring angles radians. All right? So when we're learning about radian measure or thinking about radian measure, it's very useful to think about something called the unit circle. The unit circle is a circle that has a radius of one unit, all right? And often we'll put this circle in the coordinate plane, all right? But the key is that it's got 1 unit in radius, all right? And so if that's 1 unit, then we can find the circumference. Remember, the circumference of a circle is 2 pi r, 2 times pi times the radius. So in this case, it's 2 times pi times 1, which is 2 pi. So the distance all the way around this circle is 2 pi. Okay? And now we can say that we're going to gauge the measure of an angle off of the arc. Okay? So, degrees breaks up the circle into 360 parts. Okay? A radian is going to break it up into fractions of the circumference. All right? So, let's look at some GeoGebra here that we got going on. Let's think a little bit about this here. So here we have a unit circle in GeoGebra, and we can see that the angle is 90 degrees right here, and that angle subtends is the word, subtend. It cuts off or it intercepts an arc here. And I've got the arc measured here, 1.571, which that number right now doesn't mean too much to us, but let's kind of look at what's going on here, all right? So if we take that angle, okay, and we move it around, we've got 90 degrees, there's 90, okay, and we move it around and we come here to 180. Well, what's that? Well, it's a 180 degree angle, but the arc length is exactly pi. Because remember we said that in the unit circle, notice this is a unit circle, the circumference of the circle is 6.28. 6.28 is 2 pi. Okay, and so this is half of a circle. Okay, so what we're going to do is we're going to say, well, instead of calling this angle right here a 180-degree angle, let's call that, and let's describe that angle by the arc length that it cuts off. So we're going to call this pi radians. So 180 degrees is the same as pi radians. Okay, let's see if I can get this to move again. All right, if we've got 90 degrees, let's lock it on the 90 here. See if it will. Did a second ago. There it was. Okay. So 90 degrees, well, what is this arc? Well, the whole 180 degrees was pi, and this is half of 180, so this should be half of pi, and it is. Pi divided by 2 is about 1.571. All right, so this is exactly pi over 2. Okay, if we take this and we go all the way around, full circle is, well, it's going to jumps, but there's about 6.28, okay? And there's lots of angles in between that are really nice, that are going to be useful. So when we talk about radian measure, now I can do this here now. Right now this angle is measured in degrees, but if I change the settings and I ask GeoGebra, come on GeoGebra, to measure it in radians. So now we can see that the angle is being measured in radians. So instead of degrees, now GeoGebra is measuring it in radians. And that radian measure is just the length of the arc. It is equal. Okay? So that's the idea. So radian measure is the length of the arc. And as we get into advanced math, into pre-calculus and calculus, we're going to start measuring angles as radians. All right, so one example here, we can see this if we look at arc AE. There's arc AE, that's a 90-degree arc. Okay, it's cut off it's created by this 90-degree angle. Well, that angle, ADE, is 90 degrees. I'm sorry, AOE. A little typo here, actually, AOE, huh? So this is AOE. So AOE is 90 degrees, okay? So in radians, we can find the length of that arc by saying it's 90 out of 360, because that's the angle, times the circumference, 2 pi r. So we have a quarter times 2 pi, and that is 2 pi over 4. If we multiply that, make that like a denominator 1, which becomes pi over 2. And so pi over 2 is the measure of AOE in radians. So by definition, the length of the arc is the radian measure of the angle. That's the key there. Okay? So the length of the arc that is cut off by the angle is the measure. So you can see here I put that one in there, all right? AOE, which was 90 degrees, is pi over 2. Okay? Now, one last thing here before we cut you loose on this activity. Notice we now have a way to measure angles, or to define angles that are bigger than 90, bigger than 180 actually. All right, so in a triangle and in GeoGebra, we can, in geometry, we can only measure angles up to 180 degrees. But now we can talk about, if we go farther, that angle all the way around there is more. Okay, so it's a rotation. So we think of an angle as a rotation. So we can talk about an angle as being bigger than 180 because we're rotating around a point. Okay, so here's what you're going to do in this activity. You're going to take and you're going to find the length of this arc. You're going to pick for AOB. AOB, for example, is this arc right here, or this AOB is the angle, AOB right there. And the arc is that it cuts off is the arc AB. Okay, so you need to figure out how long that angle is, find it as a fraction of pi, just like we had pi over 2 for the last one. Okay, and that arc is what the radian measure is. Okay, so you find the length of the arc, and that's going to go in here. That angle in degrees right there is 30 degrees. So we got the angle there, and then we'll let you figure out how long that arc is. And the length of the arc is the radian measure. And this important connection will be something that eventually we'll have memorized down the road. So, all right. So go ahead and find all those radian measures and we'll continue on. Okay, go explore some arc lengths. Remember, the length of the arc is the radian measure of the angle. And we'll find these ones over here will be bigger than 180 degrees. And you'll start to see patterns also as you look in these radians.